Hello, my name is Lieutenant Colonel Jimmy Jones. This program is about a rapidly produced, manufactured, on-demand flying missile rail. Now, the flying missile rail is a two-part effort. First and foremost, it's a rapid, on-demand manufacturing of a flying missile rail. The flying missile rail goal for manufacturing is produce a rate of 500 in 1 month. Now, the flying missile rail itself is a launch platform that can either launch an A-120 air-to-air missile while captive on an F-16 or an F-18 aircraft, or that it can launch from the aircraft to a pre-planned position in front of the aircraft and launch the A-120 on its own. Now, normally, what we ask for is, here's what I want and how fast I can get it in the acquisition world. Well, what this effort specifically is here's how fast I want it, how much of it can I get? And we'll talk about that through the rest. Typical expendable systems are generally life limited. For example, the service life, or the life of which a device can sit on the shelf or in storage, is generally greater than its capability life, or the capability life is how long a system works against a particular adversary or what to which it was designed. Now, a paradox is that most of our expendable devices go out and claim that it must work, but it also must be inexpensive, and that runs the problem of every time that we design it that it shall work, the costs increase. Early in our life for the Department of Defense, we created very simple, low complexity systems that were fairly rapid to manufacture. And as complexity grew over time, with the advent of the F-18, F-16, F-22, F-35, etc., those costs and the time at which it takes to develop a program has grown steadily since the early 70s. Now, the goal for this program is to take those early concepts or the early programs that were rapidly manufactured and actually modernize that through the last several generations of designs as well as manufacturing techniques brought up by the commercial industry. Now, the flying missile rail goals are to achieve a rate of 500 in 1 month. It doesn't mean that we're going to produce 500 in 1 month. It means that we achieve that rate, specifically within a month and with 500 missile rails there. So whether or not we achieve the rate at the mid or all the way through, that is a goal to actually achieve that rate. Now, certainly to achieve that, you have to allow pre-positioned components and everything in one place to be manufactured or assembled. That part's expected. Another goal of this mass manufacturing or manufacturing on demand is to minimize the sustainment cost. Normally, after we produce a vehicle or some sort of component, it sits on a shelf and requires a fair amount of sustainment in order to maintain it and ensure that it's going to work when we need it. So you can position everything to be ready for on-demand manufacturing. Now, the flying missile rail itself has a number of goals, most of which can be traded to actually achieve that rate. First and foremost, it should be, or it's expected to be, an elegantly simple design that can carry at least one AIM-120 missile. If it can carry more, that's highly encouraged, but it needs to carry at least one. Now, that AIM-120, again, should be launched from the flying missile rail either while captive on an F-16 or an F-18, or while the flying missile rail is actually flying after it's departed from the vehicle. Now, the flying missile rail itself should be compatible with 2,000-pound class hardpoints on those vehicles. There should be multiple reuses of the vehicle if it's not launched from those aircraft, but otherwise, as soon as it's launched from the aircraft, it's expendable. There should be enough room for a small powered radio compartment, and a goal for operating speed is 0.9 Mach for 20 minutes, and it should be able to go to a point in orbit or a selected number of points during those 20 minutes. Now, the flying missile rail is not required to fly in controlled flight after it releases AIM-120, which should alleviate some engineering concerns, but if it can, it certainly will be used. Now, the rapid manufacturing part, it's expected or believed that both your aircraft designers and your experts in rapid manufacturing are going to form a very cohesive and coupled team. Now, the rapid manufacturing does not at all mandate a specific process. Normally, people think about 3D printing, CNC, etc., but any manufacturing process that can achieve the rate is allowable. Details such as cost analysis of why you selected that specific manufacturing strategy, as well as the design itself, are key deliverables. A couple of examples, one of which is the end state, is if you choose, for example, a factory in a can, that all the materials are going to be pre-positioned in a place that can be manufactured and achieve that rate. Now, for the factory in a can example, if you do choose to go, for example, use a CNC and actually purchase a CNC to put in that factory, then all of the equipment and all of the code that goes along with it should be a part of your deliverables. Now, another key piece of this is no matter what manufacturing method you choose, is that the minimum number of required personnel to be trained, and also the cost analysis of how long and how much it's going to take to train each one of those folks in order to maintain this capability for a number of years is definitely a part of deliverables. Now, there's 3 phases to this SIBR, the first of which is going to be the actual design and then the evaluation of your models and your trajectory models by a third party. Your manufacturing approach and analysis are going to be delivered, not demonstrated, but your phase 2 proposals, more importantly, are going to be delivered at the 3-month point. Now, each one of the teams that's on phase 1 is going to get a base up to $175,000 for 6 months with an option of $50,000 for 4 months. Now, those teams are both your design and manufacturing pieces. So they're not 2 separate teams, but they're one. Now, for phase 2, we're going to take each one of those teams and may divide those teams up into 2 separate awards, but you're still the same team. Now, each one of those teams is one, a design piece, as well as a rapid manufacturing piece. Again, both part of the same team, but with 2 separate awards. And we're going to take up to 2 phase 1 teams forward to phase 2. Within phase 2, we'll actually go out and demonstrate and prototype key manufacturing risk reduction portions of your design. One of the goals will actually do fit checks on an F-16 and F-18, as well as provide deliverables that can show that we can actually meet vibe and flight restrictions of those 2 aircraft. Now, for each one of the base options, again, up to $1.5 million for 12 months for the awards for those teams separated out. Now, obviously, the goal for phase 2 is to get to phase 3, and that will be the actual demonstration of the full rapid manufacturing capability of a single design. While phase 2 produce some prototypes and some fit check models, phase 3 will actually go and develop and demonstrate the actual device that will go out and flight test and employ on actual aircraft. Another goal of phase 3 is actually show that we can apply this to other designs within the DoD, but that's not going to be a main effort. That's just going to be through analysis. Again, for the SIBR, teaming and traceability between design and manufacturing is absolutely a key element. Demonstrations as there is scope throughout each of the phases, to include phase 1 if your design is mature enough and you're ready. So again, the key takeaways for this is to develop a single-purpose, elegant device. Now, while I certainly will ask what else your device can do not allow those questions to give you design creep or requirements creep, if you will, into your vehicle and into your design. Now, your team and your choices to choose the correct breadth of ability is going to be a big key to success for this. Now, simplicity and, again, details, all the way from your optimized machine G-code, if you choose the CNC route, all the way up through your trajectory models are highly sought in this program. Now, operational analysis and effectiveness are absolutely not part of this effort. It is truly and simply the design and mass manufacturing of this device. Now, again, we're going to take, and the goal is to modernize the design rates that we had in the early years of the DoD and modernize those up to 2017 standards. All right, and that's a look at the Flying Missile Rail program. I look forward to your submissions.